going today, guys? This video is just going to be a quick review of how to balance chemical reactions and then me working through a whole bunch of practice problems. These are the same practice problems that are posted on the classroom. They're in the PDF called BCE Practice, just balancing chemical equations. And yeah, we're going to go ahead and jump right into this. So the review here, we're just doing a review of how to count atoms in a molecule. So right here, on this side, we've got 4 NH3, which is 4 ammonia. So we have 4 molecules of NH3. In each one, we're going to have 1 nitrogen and 3 hydrogens. So that means we have 4 times 1, we have 4 nitrogens, and we have 4 times 3, that's 12 hydrogens. And I believe, yeah, written out just a little bit clearer right there. I am not going to do a whole lot of editing on this video, so I apologize ahead of time if it looks unpracticed. For the second one, it's a little bit more complicated. We've got 2 H2Os and 3 NH3s, and you'll notice that H is in both of those, so that one's going to be the harder one to count the atoms on. For oxygen, that's pretty easy. We've got 2 waters, each one has 1 oxygen. That gives us 2 total oxygen. 2O. We have 3 NH3s. Each one of those gives us 3 nitrogen. That's our only source of nitrogen, so we have 3 Ns. And then we've got 3 times 3 hydrogens, that's 9, plus 2 times 2, that's 4, so we should have 13 hydrogens. And this is just a little chart that shows it in a little bit more detail, makes it a little bit easier to see. It's just lined up so that the H2O contributes 4 hydrogens, 2 oxygens, 0 nitrogens, NH3, 9 hydrogens, 0 oxygens, 3 nitrogens. We add those up to get 13, 2, and 3. All right, so into the actual practice. As we said last time, there are a couple different ways to do this. I'm going to go ahead and do both in this video. The first one I'm going to do kind of the longer way, and then I think in the second one I will break it down a little bit easier. So first thing we want to do is look at all the different things we have in our products or reactants. So we've got silicon, we've got chlorine, we've got hydrogen, we've got oxygen. And then on this side we'll have the same thing. So silicon, chlorine, hydrogen, and oxygen. And remember, if we have nothing in front of these, that means that it's a 1. So right now we can count out our atoms based on all of those being 1s. We'd have 1 silicon, we'd have 4 chlorines, we'd have 2 hydrogens, and 1 oxygen. On this side, we'd have 1 silicon, so that's actually balanced to start. But we'd have 2 oxygens, so that's not working out for us. We'd have 1 hydrogen, also not working out for us. And we would have, just 1 chlorine over here, which is also not working out. So all of these aren't going to work, which means we're going to have to change some numbers. So starting out over here, we see that we've got these chlorines. There's 4 on this side. This left side, there's only 1 on the right side, so we're going to go ahead and start out by making this a 4. And if we do that, that gives us 4 hydrogens, that gives us 4 chlorines. That balances the chlorines. These are now balanced. Check. And then we'll see that on this, that leaves us with 4 hydrogens on this side, 2 on this side, so we're going to need to double that, which doubles our hydrogens to 4 and doubles our oxygens to 2, which actually makes our equation entirely balanced. So we know there's a 1 here. We've got 1, 2, 1, 4. So for this second problem, we've got arsenic on the left side, as well as sodium, oxygen, and hydrogen. So those are going to be our 4 different things. I'm just going to do this from now on, so I don't have to write this all out, especially since I still can't figure out how to mute the pen. I won't make clicking noises every time. So currently we have 1, 1, 1, 1. Not so much on this side. We do still have 1 in the arsenic, but we have 3 sodium, 3 oxygen, and 2 hydrogen. Now, that means that these bottom 3 are not balanced at all. one of the very immediate issues that we see is if we want to make this NaO or Na3, that's going to make us have 3 hydrogens on this left side, and then we won't be able to balance it with H2s. So unfortunately, we're going to have to go ahead and multiply all of these by the least common denominator of these. So we're going to probably start out with 6 on this side. If we do that, that's going to give us 6Na, 6O, and 6H, which will mean we'll need 3 in this H2. That'll give us the 6 again. If we have a 2 here, that's going to give us 6 oxygen, 6 sodium, and then it's going to make us have 2 arsenic. And in order to balance that, we just need to put a 2 here. And that gives us a completely balanced equation. So this one, you should have 2, 6, 2, 3. And I'm going to be going through these kind of quickly, but hopefully it'll help you. There are a couple that you need to break down in fancy ways to make them a little easier, and we'll see that in just a little bit. This problem, start out the same way. We're going to break out down our AU, our S, and our H. So this one has a little bit fewer. To start out, we have 2, we have 3, and we have 2. On this side, we just have 1. We've got 2, and we've got 1. When you see an element by itself on this side with no subscript at all, that's usually going to be your easiest one to balance. So you usually want to save this one for last. In that case, we're going to look at sulfur. We need 3 sulfurs over here. In order to do that, we have to put a 3 here. And if we do that, that gives us 6 hydrogens. So luckily, we can put a 3 here as well. Double us up to, or take us up to 6. If this is a 1, so then we've got 3 on this side. And the only thing that's unbalanced is our AUs, and we can just put in a 2 there. So we will get 2, 3, 6, and 2, 3, 6. So your numbers on this one should be 1, 3, 2, and 3. So moving on to the next problem. This one, we start off with vanadium over here, oxygen, hydrogen, and chlorine. And what we've got on this side, we've got 2, 5, 1, 1. This side we have 1, 2 because of that second oxygen from the water. 2 and 3. So basically nothing is balanced in this equation, which is always fun. So the first thing we could try to do is double this, which is going to give us, if we leave this as 1, that'll double our vanadium to 2. That'll give us 3 oxygen. That'll give us 6 chlorine. And then in order to increase our oxygen further, we can move this one up to 3, which will give us a total of 5 oxygen. 2 here, 3 here. It'll give us a total of 6 hydrogens. And if we put a 6 in the HCl, we'll have 6 and 6. So that will balance us out on this one. Sorry, trying to cross all those out. So you should have 1, 6, 2, and 3. This one, we've got Hg. Now I'm going to do something a little bit weird on this problem. I'm actually going to keep this as OH, because those OHs are going to go together, and you'll see what I mean in just a second, and why this is very weird. And then I'm still going to have hydrogen because of this PO4, and then I'm also going to keep the PO4s together. Now, this is a strategy to make balancing these a little bit easier. You see the OHs in parentheses here, so you know they're always together. On this side, oxygen, in order to make this actually work, or sorry, water, in order to make this work, you need to break this down into hydrogen plus OH. So we can see that that's still H2O, but it gives us 1 OH for every water molecule and 1 hydrogen. And that'll make a little bit more sense here in just a second as I go through this. So on this side, we've got 1 mercury, we've got 2 OH groups, we've got 3 hydrogens, and we've got 1 phosphate group. This side, we have 3 mercury, we have 1 OH group from this water, we have 1 hydrogen from this water, and then we have 2 phosphates here. So immediately we're going to have to at least triple the Hg on this side, and that would give us 3 Hg, but it would also give us 6 OHs. Then, in order to balance that out, we need a 6 here, which will give us 6 and 6. I'll start canceling these out as I go. If we do that, we'll need to double this, which will give us 6 hydrogens and 2 phosphates, and that actually gets us to our balanced chemical equation. So we've got 3 mercuries, 6 OH groups on each side, 6 hydrogens, and 2 phosphates. And our numbers up at the top should be 3, 2, 1, and 6. For number 6, we've got silicon, we've got oxygen, we've got hydrogen, and we've got fluorine. And in the middle here, we'll draw the line. So we've got 1 silicon on this side currently, we've got 2 oxygens, 1 hydrogen, and 1 fluorine. This side we have 1 silicon, we have 1 oxygen, we have 2 hydrogens, and we have 4 fluorines. So first things first, immediately that's going to get doubled, or that's going to get quadrupled, sorry. That's going to bring us up to 4 and 4. Okay, once we do that, in order to get hydrogens balanced, we're going to need to double this, which will give us 4 hydrogens and 2 oxygens, and that makes us balanced. We've got 4, 4, 2, 2, 1, 1, and 4, 4. So 1, 4, 1, 2 for that one. Right. This one is a little bit easier. I believe I'm saying that now. Watch it be super difficult. But we've got zinc, we've got hydrogen, and we've got chlorine. On this side we have 1, 1, and 1. This side we have 1, 2, and 2. Put 1 here. Put 1 here. We're going to put a 2 here. 2, 2. That's all you got to do for that one. Oh, that should be a 1. I'm sorry. 1. So it should be 1, 2, 1, 1. Number 8, we've got hydrogen. We've got Cl. We've got lots of oxygen. And then we've got phosphorus. Now, this one looks a little bit opposite of the last one, exceedingly brutal. So to start out, we've got 1 hydrogen, we've got 1 chlorine, we've got 14 oxygen to begin with, and we've got 4 phosphorus. Now, our only source of phosphorus on this side, actually, sorry, I'll get to that in a second. So we've got 3 hydrogen, we've got 1 phosphorus, we have 11 oxygen, looks like, and we've got 2 chlorine. So on this side, our only source of phosphorus is this HPO3, and we need to get it, so we have to at least put a 4 here, which is going to give us 12 hydrogens. Oh man, this is going to be ridiculous. That's going to give us 12 hydrogens. It's going to give us 16 plus 7, 23 oxygens, and 4 phosphorus. Then, let's see, where do we want to go next? Let's try the hydrogens. So we'll need 12 here. So give us 12. That'll make that a 12. It's unfortunate. And then oxygen goes to 48, 58. What in the world? Alright. So obviously our chlorines aren't balanced at all. Let's make this a 6. And if we do that, we'll get 12 here, and then we go 6 times 7, which is 42, I hope, plus 16, which is actually, interestingly enough, 58. That worked out quite nicely. So then we've got 12, 12, 12, 12, 58, 58, and 4, 4. So 12, 1, 4, 6. All right. Moving on to the next problem, we've got 2 nitrogen plus O2 plus H2O goes to HNO3. So we have nitrogen, oxygen, and hydrogen. You'll notice on this problem that we've got 3 reactants all going to 1 product, which means that this number here is going to be the important one. And when we're changing things around, we're going to have to manipulate this one probably the most. So we've got 2 nitrogens, we've got 3 oxygens, 2 from here, 1 from here, and 2 hydrogens. And on this side, we have 1 nitrogen, we have 1 hydrogen, we have 3 oxygens. So the oxygens are balanced, but we're going to have to change every number in this every time we change the number in front of this. So if we made this top number a 2, and I'm not going to put it in until I have the answer, just because erasing is difficult on this, we'll get 2, 6, and 2, because everything just doubles. And if we do that, we've got nitrogens and hydrogens balanced, but we can only add 2 oxygens at a time from the pure O2. And if we change this number, we're going to change our number of hydrogens. So let's try doubling this again to 4. So now we've got 4, 12, and 4. And if we do that, we can put a 2 here, put a 2 here, and that'll balance out our nitrogens and our hydrogens. And then we've got 2 oxygen plus however we make here. So we need 10 more. And since each one is 2, we just need to make this a 5. And then we should get 5 times 2 is 10, plus 2 times 1 is 12. So that would balance us out. So we want this one to be a 4. So we've got 2, 5, 2, and 4. And the last one we're going to do today, NH4, NO3 goes to N2 plus O2 plus H2O. So this is kind of the opposite of that last problem. So we've got nitrogen, we've got hydrogen, and we've got oxygen. This is probably written this way because it's in some form of organic chemistry formula. It's ammonium nitrate, but we're not going to worry about that really. We just can think of it as N2H4O3. So we've got 2 nitrogens here, we've got 4 hydrogens, and we've got 3 oxygens. Currently on this side we have 3 oxygens, but we only have 2 hydrogens. In order to get 4, we'd need to double this, but if we double this, we're going to add another oxygen, so we'd have to change this one. So let's start by doubling everything on this side. It was 4, 8, and 6. And if we do that, we can just easily put a 2 in here to make this 4 nitrogens. To get our hydrogens, we need this to be a 4, which would give us 8 hydrogens and 4 oxygens, and then we just need a 1 in this O2 to make 6. So we should have 1, 2, 4, ignore that, sorry, and 2. And just to double check that one more time, NH2O, make sure I got it right. We've got 4 nitrogens on this side, we've got 8 hydrogens, and we've got 6 oxygens. Over here we've got 4 nitrogens, we've got 2 oxygens plus 4 oxygens, that's 6, and we've got 4 times 2, which is 8 hydrogens. So 2, 2, 1, 4. So that's all the practice problems from this worksheet. Hopefully that helps you guys out. I can provide more practice if you need it. Just email me. I've got a couple other worksheets you can do, but I'm guessing that none of you are going to want to do a ton of these over your online schooling time. I'm sure you've got better things to do. But that's it for this video, so I will see you guys next time.